Good morning, good afternoon, everyone. Welcome to the Avi Networks Terrific Tuesdays webinar series. Today's topic is proof that poor application delivery is not always a network issue. We're going to look at inline real-time analytics to pinpoint application degradation issues without any agents, span ports, or monitoring fabrics. My name is Ashish Shah, and you can reach me at ashish@avinetworks.com. This webinar will be recorded, and you can ask questions on the question and answer window on your GoToWebinar panel. All right, so let's get started. As a network engineer, I'm sure you've been in a position where you have to prove that it's not a network's problem that an application is running slow. It's as if you're guilty until proven innocent. For example, let's say you have a collaboration application that's running slow. You've been told, fix the network issue. Must be the network, right? Well, it could be the network. It could be the WAN. It could be your data center network. It could be the servers themselves, or the application itself might be misbehaving. So where do you start? You can start with a network performance management tool, Gigamon or Nagios or NetScout or any other. You can look at your favorite TCP dump output, right? That's always fun. Or you can call up your server guy and say, can he sift through the server logs and see if he can find any insights into that? And you might as well call your application guy and say, well, what about APM tools like CA or AppDynamics or New Relic? Is there any insight that they can give you? So as you can see here, pretty soon you have finger pointing going on between your network, application, and server teams. And hours go by, and you're no closer to the resolution. So is there a better way to go about this? Well, yes, there is, and we'll look at it how we can do that with the Avi system. Before we do that, let's understand what Avi Networks does first. So Avi Networks connects the two isolated worlds of monitoring visibility on one end and application delivery on the other. And Avi Networks has built what we call analytics-driven application delivery solution. So where does Avi Network solution sit in your environment? So just like any application delivery solution, which is a full proxy, TCP, HTTP proxy, on one end, you have your users, which could be on desktop or mobile. On the other hand, your applications could be running on on-prem data center or in a cloud. The Avi solution sits in between them and provides load balancing, application security, and application acceleration functions, the typical ADC functionality, as well as end-to-end visibility and analytics, all the way from users to the infrastructure to the application. The Avi solution integrates with your VMware vCenter, OpenStack, or any of the cloud management platform, as well as DevOps tools like Puppet, Chef, and so on. All right, now that out of the way, let's understand a little bit more about the Avi's product before we jump right into the demo. So Avi solution, as I said, it's a completely software-based solution built on SDN architecture, and it provides inline analytics and application delivery. The brain of the system is the Avi controller, which runs as VMs or a set of VMs for high availability. The Avi controller is the centralized policy engine and analytics engine. It provides single point of management, control, and integration with the infrastructure components. Avi service engines are the distributed data plane. They are the ones that implement your load balancing and security and acceleration services. They also act as data collectors, collecting hundreds of metrics every second. The Avi service engines are completely managed by the Avi controller. The full life cycle is managed by Avi controller, so you don't have to individually manage these micro load balancers. And on top of the Avi controller, through the REST API, is our Avi UI. That is your analytics and ADC dashboard, providing real-time reporting, visualization, and management capabilities. All right, so now let's wear the network engineer hat again, get your coffee, sit in front of your ticket dashboard, and see what we have to debug today, what we have to troubleshoot today as a network engineer. The first ticket, well, that's the collaboration app that we started with in the beginning. Users are complaining that there is an overnight degradation in the collaboration app, and the users are experiencing high latencies. Looks like the impact is widespread. We have almost everybody seeing the problem, and it's happening consistently. So it's a pretty severe problem. In a typical environment, you can start with packet capture, TCP dump, and so on. Let's see how we do with the Avi solution. So first thing I'll do is log into the Avi UI. So let me do that. And when I log into the Avi UI, the first thing that comes across is the dashboard, the application dashboard. The application dashboard, again, presents all the applications, and they are color-coded by their health. We'll get to them, these in a minute. Let's go directly into the collaboration application. All right. So what I have here is the application dashboard for the collaboration virtual service. The first thing you notice is we have an end-to-end timing dashboard. Now, this is something unique to the Avi solution. What end-to-end timing dashboard measures is the total round-trip latency between the users all the way through the networking infrastructure and server infrastructure to the application and back. So in this case, for example, over the last 6 hours, the users are taking about 35 milliseconds to hit the Avi solution, which is running in the data center. So this is pretty much the WAN latency. The server latency round-trip time is about 1.5 milliseconds. It's pretty good. The application response time is over 300 milliseconds. This is the time the application is taking in the request, churning out the response. And the overall data transfer time is just under a millisecond, with the total round-trip latency over 360 milliseconds. So with just this dashboard, you can clearly see network is not a problem, right? It's the application response time that's taking over 90% of the total latency.
At this point, we can hand over the issue to the application team because it's not a network issue, right? Well, we can do better. If you remember from the ticket, the problem started happening overnight. Before that, it was all okay. So let's change the view to 24 hours dashboard view and see what's going on. Aha, as you can see here, clearly that
something happened around 10 o'clock that resulted in this application response time going up to over 300 milliseconds. So clearly something changed. Let's see if we can figure out what changed at that time. So I see that there is a config event that happened around this time. We click on that. And as I go down and see that around just before 10 o'clock, there was a configuration done on the pool servers. Let's drill down and see what was the configuration. Well, this is the diff of the configuration. It looks like one of the servers potentially was disabled. And we can figure out something more on that. Looks like one of the hosts, web app 3, was disabled around the time that started showing high latency. So at this point, we have isolated the issue to some server config change that resulted into high application response time. So not only we have resolved that it's not a network issue, we've also helped our application teams and server teams saying, can you look at this server and say what went wrong? All right, that's great. So back to our ticket dashboard, one down. Let's look at the next one. The second ticket says that there is an intermittent issue accessing an internal website. Again, the impact is pretty widespread. However, it's happening only 20 to 30% of the time. Now, as a network engineer, I'm sure you know that these intermittent issues are the toughest to debug. Let's see what we can do with the Avi solution. Let's go back to our dashboard. Let's go back to a 6-hour window, and let's look at the internal website application. All right, so first thing you notice here is there is a yellow health score, right? So the application health is suboptimal. You can clearly see that with the health score. The health score is composed of 3 elements. The application performance, which is measuring how the application is doing and how end users are experiencing that. A resource penalty score, which measures the infrastructure, how hot the infrastructure is running. So for example, if you're running high on CPU or memory in your virtual infrastructure, we flag that because that's a potential risk to your application performance. As well as an anomaly penalty, which measures if there is any anomalous behavior that's happening that's unexpected, and that can result in a future degradation of the application performance. So in this case, it's quite simple. Looks like the application performance is suboptimal, right? It's yellow. So let's see what's going on here. So we look at the insights and look at the performance score and see what's going on here. And looks like the response apdex is suboptimal. So the responses are not optimal. As I drill down here, at the responses, I see that there are some tolerated and frustrated responses. Okay, that might be an issue. And I see the pie chart for the response code breakdown. And over 20% of my responses are resulting in a 404 or a 400 error, which means usually a 404, a missing link, or a missing resource. It's quite likely that these 404s are contributing to the performance degradation of the health score. Okay, so now let's drill down into what's causing the 400 errors. I will go into a client logs dashboard, and I'm going to display all the logs, not just the significant ones. So let me give you a quick overview of what this dashboard is. As an HTTP and a TCP proxy, we are capturing full HTTP transaction logs and capturing relevant information and then correlating that with the other metrics in the system. So in this case, for example, over the last 6 hours, we have captured over 90,000 logs. And as I just scan here, I see a few 200 responses, but also some 404 responses. Let me just click on that. So as I clicked on that, the Google-like search bar at the top was filled automatically with the query which says,
show me only those logs that have response code of 404. We'll see there are about 20,000 such logs who have a 404 error.
How can we analyze this further and see what's going on in the system? On the right-hand side, we have a log analytics dashboard. And here you can take these logs and slice and dice it in various different dimensions. So in this case, we know that there are some missing resources. Let's slice the data with the URL paths. So in this case, out of these 19,000 logs, over 99% are because of two missing images. Two pictures, and one picture and one icon are missing on my website. There's some other 404s, but for the most part, they're not significant. Almost all of the 404s are coming from these two images. All right? So now we have narrowed it down to missing files on some or all of our servers. Can we find out which of the backend pool servers these are missing on? Let's look at the server IP address analysis. And as we do that, the system is going through the logs and displaying which servers, backend pool servers, have these errors. And looks like out of these two pool servers, it's a .129, which has resulted into these 404s being generated. So at this point, we have not only isolated the problem to missing resources, we have narrowed down it to a specific server on which these files are missing. We can export these logs. We can export this log as a CSV, and then
send it to the app team and tell them which two files are missing, what servers, and we are done. Okay, let's get back to our ticket dashboard. Two down. On to the third ticket. Some users are complaining about high application latency by accessing the internal HR app. Only some users are affected, but for them, the problem is consistent. Let's go back to the Avi dashboard. If we go to the HR app dashboard, let's look at the end-to-end timing. Looks fine, nothing major here. The health score is 91, which is good. Now, since the problem is affecting only a subset of the users, let's go to the client logs and do a more detailed analysis.
So I'll go back to our familiar client log screen, enable all the non-significant logs as well, and let's see what's going on. So this is an HR app. This is accessed by internal employees. So let's see where these requests are coming from. So what I'm going to do is I'm going to look at the location tab here and see that there are 4 branches, which we have 4 branches here from Paris, London, Singapore, and Boston. They're accessing this application. And it's a pretty even distribution. Okay, we still don't know who is having a problem right now and what the root cause is. Okay, now let me let me do is go to the end-to-end timing tab, because I know I'm trying to figure out which users are having high latencies, which are not. Right now, I've charted the histogram of the end-to-end timing latency. So in this case, over 80% of my users have under 100 milliseconds of latency. That's pretty good. But about 12% of the users have 400 to 800 millisecond latency, and about 6% of the users have over 800 milliseconds of latency. Okay, so clearly we have a problem here. Okay, so let's look at one of those. So I'm going to now click on this one, and immediately the Google-like search bar got populated with this query which says that show me only those logs which have total response time of 400 to 800 milliseconds. Okay, so we have these over 4,000 logs. Let's drill down one of them. Okay, let's see where this is coming from. Okay, looks like this is coming from the Boston branch, somebody running an iPad, and of the overall 760 milliseconds of response time, almost all of it is the client-side RTT.
This gives us a hint that something is going on the client RTT side. Let's check out who these users are. Note that we are displaying only those logs which have 400 to 800 millisecond latency. Let's see which location these users are coming from.
In this case, voila, all of these logs are from the users who are in the Boston office. So looks like people in the Boston office are having a problem. Maybe they're, as I said, the ISP has something going on at this time, or the WAN link that's connecting that to the data center has a problem. We can hand over this now to our WAN team and say, can you please take a look? Looks like Boston's having a problem. Here are the details, and we're done. All right, great. 3 down. So we're taking care of the tickets this morning. Let's drill down to some new tasks. So we have an application development team. They have deployed a new Apache web service, web application, and they want us to deploy monitoring and application delivery services. Now, normally, this would take hours or maybe even days, right? Maybe you have to order a new appliance or at least carve out space on your existing appliances, spend time to configure span ports on your network switches, connect all together, and so on. Let's see what we can do with Avi. We've been told that there are 4 Apache servers. They're named 1 through 4. They're in VLAN 500. We don't know what the IP addresses are, but that's fine. Let's go to the dashboard. So let's go to the dashboard, and let's create a new virtual service. Okay, let's give it a name. Let's call Apache Web App VS. Let's give it the VIP IP address or a DNS name if you have it configured. In this case, we have an IP address in the DNS system, so it picks it up. And now we're ready to configure the pool servers. Now, I don't have IP addresses. That's fine. Let's search the network for what are the servers available there, and we'll pick up the Apache ones from there. We know it's in VLAN 500, so we're talking to vCenter at this point, getting all the information about the networks. We got the VLAN 500. Let's search for Apache. We see 4. Let's select all of them, add, and save, and we're done. Took about 30 seconds. In 30 seconds, I have deployed inline analytics, monitoring, and application delivery solution. There you go. Within a few seconds, the service engine came up, virtual service is created, and we have the application ready to go. At this point, we can call our app team and say, well, go ahead, your services are ready, go ahead and use them. However, the Avi solution can also provide much more insights into the usage of the application. And let's see what kind of visibility it provides. So in this case, assume that this application plays out over time, and as these data is collected. For now, for this demo, I'll go to one of the applications which we have already deployed, the internal web application that we looked at. And now I'm going into the Client Insights dashboard. The Client Insights dashboard is a Google Analytics-like view for your internal application. So in this case, it's measuring the geography distribution of where the users are coming from, the device, browser, and operating system insights, as well as the top URLs. This is very powerful in the application team. It's also very useful to know that about 50% of the users are desktop-based, computer-based, and the other 50% are mobile. Okay, let's see who are these phone users. So it looks like for the phone users, all of them are using iOS and mobile Safari. What about tablet? I click on tablet. Again, all of them are using iOS and the mobile Safari browser. So if I were an app admin, this is very powerful information for me because I can now say that if I have to optimize the experience for my app, I should focus on iOS with Safari as the browser over Android or any other browsers on iOS. Again, this is very, very useful as I develop my application and optimize its experience. And we have a multi-tenant system, so you can give a read-only access to an app team, especially if you have a DevOps initiative with the CI/CD model, where they can immediately see how their applications are being used, what the user experience is, what resources are being accessed, and so on. So they can optimize the application experience in real time. All right, so 3 tickets down, 1 new task down. Let's see what we can do, what else we can see from our application dashboard. I have one of these apps called SaaS application. I'm deploying a SaaS application here, and I see something funny here. I see that the health score is taking a dip every so often. That's something peculiar. Let's see what's going on. Oops. Let me go back to the application analytics dashboard, and I can see that every 2 hours to 3 hours, I see a huge spike in the latency. And correspondingly, if I look at the throughput, there is a dip every couple of hours at the same time, right? And you can see a lightning bolt symbol here, which indicates that we have identified this as an anomaly. What Avi does is, as I said, right, it's baseline the performance of your application, and anytime it sees any latency jump or performance dip or any other significant change, it's going to flag it as an anomaly. And when I click on this anomaly, lightning bolt, at this time, what I'm also doing is all the metrics and data I've collected from my virtual infrastructure, from my user analytics and my Avi solution itself, I'm trying to measure that when the throughput went down suddenly, which other metrics had a significant change at the same time to see if I can correlate these metrics and find the root cause. In this case, when the performance dipped, which means there was a lower deviation, I'm interested in which other metrics had a higher deviation. Okay, so again, make sure that I'm here at this point, and in this case, it refresh itself. I'm going to sort by deviation. Excellent. So I have a latency deviation, and as you can see here, just when the performance dipped, I had some latency, some disk issues, CPU usage. It looks like CPU on one of my application servers went up to 99%. On the same guy, also the total disk latency increased significantly. So I'm pretty sure at this point that something is going on that server where every couple of hours there's a cron job that's running potentially that's spiking up the CPU to 99%, and that's resulting in my application performance to go down. Okay, and I can go down to my app team and my server team and say, can you please take a look what's going on here? All right. So what have we done in the last about 22 minutes? We have not only taken care of root causing and isolating 3 tickets, we have deployed on new application delivery and monitoring services, and we have proactively identified a performance anomaly and even isolated it to a particular server.
Something that would have taken hours, if not days, with your legacy solutions. Okay, that brings us to the end of the presentation, and we're ready to answer questions. If you want to have the power of inline analytics in your environment, if you want to root cause your application degradation issues without any agents, span ports, or monitoring fabric, if you want a Google search-like experience for your network traffic, and if you want to reduce your mean time to innocence, that is proof that it's not network's fault when the application is slow. Check us out. Our website is avinetworks.com.
There's a free software download available for you, or you can also instantly log into our online sandbox where we have a few applications that you can play with on a live setup.
Okay, Ashish, I think we're getting some questions here. So everything that you showed over here, where was the setup? What was the setup, all these applications that you talked through?
Excellent question. So in this case, these applications are running in my data center in a VMware virtualized infrastructure environment. and the applications are being accessed in many cases by internal users and in some cases by external users.
Okay. We have a question from John. And John's asking, you talked a lot about inline analytics. Can you just explain that in a little more detail? How does it compare with some of the tools that you already have?
Excellent question, John. So the inline analytics, what it means is that as an application delivery solution, we are sitting in line between your users and your applications. And as the traffic goes through Avi solution, we are constantly collecting hundreds of metrics every second. So if you had a system of, let's say, 10 application servers in the backend, you're collecting millions of metrics every hour, analyzing them, correlating them across users, infrastructure, and applications, and providing you with actionable insights. The current solutions that you have today, you have a separate tool for network performance monitoring. You have a separate tool for your server logs. You have a separate tool for your APM environment. There is no correlation between these tools. These are disjoint tools. And more importantly, because these are disjoint even from an application delivery perspective, there is no closed loop between visibility, seeing what's going on, and actionable insights that you can do with an Avi's application delivery solution. So with Avi's inline analytics, you can close loop it to the application delivery, make automatic changes to the infrastructure, to the configuration, to make sure that the SLA is constantly maintained.
So I think what you're saying is, today the connection between a monitoring tool and an application delivery controller is a manual process. What you've done here is you've kind of automated that into a single integrated system.
That's right. It's automated based on machine analysis and big data analytics in real time.
Okay. We have one more question here. So what kind of hardware do I need for this Avi ADC?
Excellent question. So it's a pure software solution that runs on your standard x86 servers. So if you have VMware vCenter environment, it just runs as a VM. If you had a cloud with an OpenStack-based cloud or a vCloud Air or AWS, it'll run again as just a VM there. It also runs in a Docker environment. So it doesn't require any custom hardware. It runs as a pure software solution.
So there's no hardware shipped by Avi Networks?
That's right. It's a pure software solution that you download on our website.
All right. Here's the next question from Palak. How is the WAN latency from the end user to the load balancer front-ending the server measured?
It's a good question. So because Avi's solution is a full proxy, it's a TCP and HTTP proxy, we're able to measure the round-trip latency between the client devices or the end users and our load balancer.
All right. So what would you say, this is another question from James, what's the major difference compared to an ADC from F5?
Very good question. So the traditional appliance-based ADCs, whether it's F5 or anybody else, are not optimized for the software-based cloud-like environments. That's one. So the form factor is definitely one major difference. So you have to manage individual devices separately. There is no elastic capacity. That's one issue. The second issue is none of the existing application delivery solutions have built-in monitoring or analytics capabilities. Definitely not inline analytics, the type of services that we provide. And as a result, there is no closed-loop system that Avi solution is able to provide, from measuring the performance data, acting upon it automatically, and optimizing the application delivery performance.
Specifically, when you compare with even, let's say, a virtualized or a virtual ADC solution, what's the difference that Avi brings to the table?
So very good question. So the virtual appliance solutions from the existing ADC vendors is nothing more than a software port of their hardware appliances. So as a result, the operational model is still static. You have to configure each of these devices separately. You have to manually place them in your virtual infrastructure. You have to connect them, plumb them manually into a networking infrastructure, and then you have to manage the capacity again manually. With Avi solution, with a centralized controller and distributed data plane, centralized controller is a single point of management and operation. So you provision the policy on that controller, and Avi controller automatically spins up the service engines and provides the load balancing and analytics capabilities.
All right, we have a next question, which is, are there any performance issues with the software-based solution? Well, Avi's solution is a high-performance elastic solution. It utilizes advances in the Intel x86 CPUs, which are increasing in performance every 12 to 18 months. Additionally, with a distributed data plane, Avi can automatically scale out its performance dynamically by adding new service engines. You will find literature and videos on our website demonstrating on-demand scale-out of Avi's solution. Okay, looks like we have no more questions at this point. If you do come across any more questions, reach us out. My email is ashish@avinetworks.com. Thank you for attending the webinar. Goodbye.